Hello everyone, my name is Grace Ma. I'm a music student from the University of British Columbia in Canada. Today, I'll be talking to you about the very fascinating and very complex topic in music theory titled When Proportion and Tonality Misalign, an analytical issue in several keyboard pieces by Bach as examples. Let's talk first about what my field of study does. For me, the study of music theory consists of using certain musically sensitive, intuitive, and convincing methods to understand, conceptualize, and interpret a piece of music in a way that transforms the series of air molecule vibrations to a coherent and meaningful entity. And pop and jazz musicians of the past century, from Duke Ellington to the Beatles and even Feist, they were also greatly influenced by concerned with this tradition, even though their approaches are greatly different from what we'll be talking about today. For my research, I'm particularly interested in the methods of Western classical tradition for the 500 years from the middle of the 15th to the early 20th century. I'll try to interpret and articulate a larger message of composition by examining how music progresses from one segment to the next, and how overarching meanings will emerge from that progression. For example, a key feature of common practice music, that is music from about 16th to 19th century, is that it's rigorously monotonal, and that means there's only one key associated with any one piece. There may be modulations to different but related keys within a piece to add interest, structural division points, and form to an otherwise static unit. While the motion within the monotonal scheme creates form, other musical elements or parameters can do so as well. In fact, the conception of form based on melodic and rhythmic motifs and the conception of tonal structure based on harmonic processes which govern the fluctuation of keys are two of the most fundamental ways of understanding a piece of music. However, by articulating an organization of structural time points, these methods also produce the large-scale, purely mathematical proportions of a composition. Theorist Roy Howat claims in his study of early 20th century French composer Debussy's music that purely mathematical proportions are also essential in the meaning of music. It is conceivable then that all parameters of music, like melody, rhythm, and harmonic processes, should align in agreement with one mathematically definable proportion for the music to make sense. However, that obviously doesn't always happen, and when various parameters fail to align, Howard explains that individual parameters would add up to create one overall proportion. However, such an explanation does not do justice when we are talking about tonal scheme contesting with proportion, just because how deeply rooted and fundamental tonal structures has been, up to and including Debussy's time. This can be so damaging to the integrity of a piece that the more you know the piece, the more it may seem like a pair of McDonald's golden arches, with one arch shifted higher than the other. That's a visual metaphor. So, for the interest of time, I'll only be covering two analytical examples for my paper, the E major and E flat major two-part inventions by Bach. These are simple, transparent pieces that most classical musicians would know, and yet they possess enough quirks to be surprised and puzzled by. First, I would like to use the E major two-part invention, that's the name of the piece, to show a normal case in which the motivic thematic proportions and tonal plans align as expected. Let's listen to it first with the score. I forgot to say that score reading is not required, but if you can, and I try to lead you along, you're encouraged to follow along if you can. More important things, the analysis, the E major invention, it's divided into standard rounded binary, or we'll skip over this, starting in rounded binary or ABA form, moving from the home key with E major. Let's see, this laser pointer, I can't find this pointer for some reason. Let's see if you find it. So it begins in the key of E major, and then at the end of the A section, it moves to 5 of E major, and which is a standard movement, harmonic movement for any piece written in this period. And B section moves to 3 of G sharp minor here, and for the A section, return of the A section moves back to E major. So the section, the division of section, obviously matches up very well with the harmonic plan that's part of it. However, this sort of very neat alignment of thematic and harmonic plans does not always hold true, as we'll see in the next piece. So this graph basically just shows that the 3 sections is about 20 to 22 to 20 measures, and when they add up, it's about a 1:1 ratio, which is have the same thing over 3 times. The next piece is a lot less orthodox. It's the E flat major 2-part invention, and again, we'll listen to it with the score and just follow the lines as best you can. Okay, so the analysis for this piece is a lot more complex than the E major invention. We'll just show you some of the results without going into too much about the methods. In the very beginning, there's a 4-measure, at the very top, there's the 4-measure thematic unit. It is repeated with the right-hand, left-hand switch. Starting with this measure right there, and then it's followed by the 3-measure transition, and then the whole thing gets repeated again. In fact, the 8+3 structure gets repeated 3 times, which creates a 1:1:1 ratio, once again, just like the E major invention. However, the problem is that for this piece, each of the structures that gets repeated is in a different key of its own. The first is in E flat major, 1. The second is in C minor, 6. And the last one is in A flat major, 4. So the numbers just give you an idea that they're in different keys, which is problematic because the monotonal tradition and requirement does not fit. But how is it possible to explain this piece in the thing that works? Because how can Bach write something that doesn't work? I'm going to explain why. Okay. So I'm about to explain the second section. So remember, we have 3 equal arches again. The second section goes to 6 of C minor. And in the middle of the second section, we have top. Okay, this one. I still don't see the point.
It's just working. It was just working.
It was just working. No. I wasn't so sure. Okay, at the very top, in the second sort of section right there, on the very top, it goes to F minor, to F minor in the middle of the second section, which gets prolonged for a long time to the beginning of the third section, displacing, remember it was the 4 of A flat minor, gets displaced to the middle of the third section. And in this way, we have a very neat 1-1-1 proportion. It gets completely destroyed. Roy Howard might have preferred this representation. However, the tonal structure completely destroys it. So what can we learn from this kind of distortion or misalignment? So in some concluding thoughts, I'm hoping that my research will encourage the theorists to reconsider proportion as an only means of analyzing music. As we saw, though proportion can neatly organize a composition, it alone can also miss out on important features. Perhaps analysts shouldn't be satisfied with proportional analysis on its own, as if nothing else really describes a piece. In addition to researchers like Howard, emerging field of music theory is looking at modern 20th century repertoire like Debussy and Stravinsky using musical parameters more typical to earlier music, like the tonal plans that we looked at. And the value of such research is in some ways shown by my study. At the same time, however, we also realize that newer analytical methods, like Howard's, isn't entirely bogus. And it can add interesting interplays as one of the many significant musical dimensions that's intuitive, perceivable, and neatly organized as a composition for the mind to follow. You guys might have some questions.